This video is about flow control, which is an important feature of TCP. UDP does not have such a mechanism. Flow control is also a task of the data link layer, but TCP's flow control is an end-to-end flow control. The scenario is as follows. There are two end systems that communicate with each other. One end system has more capabilities and can send data relatively quickly. The other system has fewer capabilities and cannot deal as quickly as needed with the data that it gets from the first end system. This means that data is sent through the network and maybe affects the transmissions of others, but in the end this is useless because the destination end system is overloaded and drops the data. In addition, TCP as a reliable protocol resends lost data so that data occupies the network several times. As a consequence, a feedback mechanism is needed to avoid this situation. The destination end system has to provide a notification if it has difficulties with the data processing. TCP flow control leads to an adaptation of the source's data rate. The picture shows the destination side where we find a receive buffer. It is filled with new data received from the network via the IP layer. The application fetches data from the buffer. In the shown situation, the buffer is partially filled. It contains some data, but there is also some free space. This free space is called the receive window. The concept of TCP flow control is that there is a field with this name in the TCP header. This means that within each TCP segment, the current free space in the buffer is provided to the communication partner. In this way, an adaptation is possible so that not more data than available free buffer space is sent. If the receive window becomes 0, then the source side is not allowed to send more data. However, on this slide we see that a problem can occur if the receive window is 0. As just mentioned, the source has to stop to send data in this case. If the destination side has confirmed all segments, it may also do no further action. This is a typical case if it is, for example, a file transfer where one side sends the file and the other side only confirms the reception of the file's TCP segments, but does not send own data to the first side. So in this case, also the destination side does not send any segment. Since both sides do not send further segments, there is a deadlock. It is therefore necessary to specify an exception here. To be able to check whether there is again some free space in the receive buffer, the source can send TCP segments with 1 byte payload data. The reaction can then be that there is now again some free space in the buffer, so that the receive window is no longer 0, or the buffer is still completely full. In the latter case, again, receive window equals 0 is sent in the acknowledgement segment. In this case, the source can try again several times to check for free space later. At the end of this video, I would like to mention a frequent misunderstanding. As you have learned, flow control does not mean that there is a constant flow of data. Data is rather transferred with a high data rate until the receive buffer is completely full, and then the source has to stop the data transfer for some time. Later it is resumed with a high data rate, then it may have to stop again, and so on. There is also mechanisms that want to achieve a relatively constant data rate, but they are called traffic shaping. Please refer to the leaky bucket or token bucket algorithms to learn more about this topic.